Creatinine. All the different places that you might have to run to look for the relevant information of creatinine. It's all here. What does that mean? What is the normal mechanics of creatinine? What does it mean to you in terms of interpretation of creatinine so that it can help you diagnose your patient? Remember, this is going to be part of your laboratory investigations. And is it the only thing that you're going to use to confirm? No, but it's a darn important one. What is creatinine? Well, begin. It's a breakdown product of skeletal muscle. And how often does that occur? All the time. Constitutively. Keep that in mind. Constant release into the bloodstream. Once again, because your muscle is breaking down, you get it into your bloodstream. Do you remember as to what the normal levels of creatinine is? Well, I want you to think of 6 and 12. You double 6 and you get 12. It is 0.6 to approximately 1.2. Keep it simple. There are so many different things that you need to memorize, right? And a couple things here, and perhaps may help you keep it in mind. But 0.6 to 1.2. How does the kidney handle creatinine? Well, I want you to go into the plasma. I want you to go into the afferent arteriole. I want you to arrive at the glomerulus, and I want you to filter through. Does creatinine get filtered? Is it small enough for it to get filtered? It is. So it gets filtered. Correct. Okay, next. As it gets filtered, well, you will continue through your glomerular capillaries, and you end up on the efferent arteriole. Are you there? And you continue through the peritubular capillaries. We call this what? Vasa recta. And you tell me what should happen around the PCT, proximal convoluted tubule, and its communication with the peritubular capillary. Are you with me? Are you there? Next. Well, what kind of mechanisms are taking place between the PCT and the peritubular capillary? Two major mechanisms. One would be secretion, and one would be reabsorption, right? Okay. So of the two, which process is creatinine following? Secretion. What does secretion mean? Secretion means you're always, I don't care where you are. What does that mean? You could be in the intestine. You could be here in the nephron. Secretion always means you're secreting into the lumen. What's in the lumen here? The PCT, proximal convoluted tubule, and the lumen is the urine. Creatinine will be slightly secreted. Is it filtered? Yes. Is it secreted? Yes. Keep that in mind. Let's continue. It is not reabsorbed. Is that clear? It's not reabsorbed. What does reabsorption mean? Once again, you could be in the GI or you could be in the nephron. Those are two major organ systems where secretion and reabsorption is a major function. You want to keep these in mind. Many pathologic conditions in which there might be excess reabsorption or excess secretion. And you'll see as we walk through many of differentials. Creatinine is not reabsorbed. It doesn't come back into the blood, period. That's important. It's only slightly secreted. So therefore, when something gets filtered and it gets cleared, what's cleared mean? It's what you are actually analyzing when you get the urine out. Meaning to say, literally, and I'm going to be rather dramatic here, in the toilet. That's clearance. Okay? There's a difference between clearance and filtration. Filtration is you're moving from the glomerular capillaries, from the afferent arteriole tuft of capillaries, and into the glomerulus. That's it. That's as far as filtration goes. Is that clear? No pun intended. Clearance means what you actually are analyzing in the toilet. What you actually excreted. My point is this. So, if creatinine gets filtered, does it do that? Yes. Does it get reabsorbed? No. Does it get secreted? Slightly. Which means that clearance will be greater than, or less than, or equal to GFR. That's your next big question. Think about that. Close your eyes. Listen to what I'm saying. Conceptualize this right now. Clearance will be greater than GFR. What does that mean, Dr. Raj? It means that you are, because of slight secretion, will be an overestimate of what is actual filtration. Now, how are you, as a clinician, going to use all this information? Well, there's a couple of tests that you can do with creatinine, which we will then use, or you will then use in practice to measure or analyze or assess the function of your kidney. Okay? And there are two ways in which you can then use creatinine to assess the functionality of the kidney. You can either use what's known as creatinine clearance, which is extremely cumbersome, or you can use the surrogate marker, meaning you will then measure the amount of creatinine in your plasma. And how do you do that? Well, that's a blood test. Okay? All right. Now, what was that 0.6 to 1.2 we were talking about, that level? Is that the measurement that you're going to find as a marker in your blood, or is that part of what's known as your creatinine clearance? You tell me. That's your plasma, isn't it? So you're going to measure that 0.6 to 1.2 is a very quick general functioning assessment of the kidney that you're going to get from the blood. Keep that separate from what we see here. This is creatinine clearance. So what does that mean? You're going to give your patient a container, and you're going to tell this patient for approximately 24 hours to urinate in that container. Does that seem rather cumbersome? Sure. Does that mean that you are dependent upon the compliance of the patient? Yes, you are. A lot of factors, a lot of ifs. But if done properly, it is a pretty good marker, once again, of renal function. Now, because of that slight secretion, we just said that it'll be greater than GFR. Understand that point. Do not just breeze through that. GFR is equivalent to filtration. Clearance is what you're actually evacuating from your body. Because of slight secretion, I repeat once again that creatinine has greater clearance is greater than GFR. Used as an approximation for GFR. What is CRCL? Creatinine clearance. How do you assess this test? This is not the blood test. This is the one in which you're measuring how much creatinine is actually being cleared.